Lesia Guinn from Biomedical Engineering will talk about infections made predictable.
I know we're almost ready to let go of our horrible COVID memories. We're entering a mask optional phase, but today I'm still going to talk about hospital visits. Ideally, when we're admitted to the hospital, we want to be discharged exactly when our condition gets treated. Instead, many patients are at risk of developing long-lasting secondary hospital infections, causing the patients to linger around months longer, like in the picture, hence the hospital bed shortage. Some of these infections can be more severe or even lethal. For example, 8% of COVID lethal cases since the beginning of the pandemic were caused by bacterial secondary infections in the later stage of the illness. So why can't we prepare for them better? Why are secondary infections so elusive? First of all, microbes adapt to antibiotics commonly used in the hospital, and this phenomenon is called drug resistance. They also adapt in multiple ways, many of which are currently unknown, so it's hard to design a drug for every particular case of drug resistance. In other words, secondary infections are unpredictable, and while we do hope our primary condition gets treated following a certain course, a secondary infection might not. In our lab, we study drug resistance and try to predict certain biological processes based on the very small scale events that shape every particular case of drug resistance. We visualize the spread of an infection with microbial growth curves. And in fact, you watch those curves multiple times a day. Remember the curves of COVID spread? That's what I'm talking about. It turns out that every infection spread curve is unique because it may be shaped by different events. Similar to a face recognition tool on your phone, we can now recognize different shapes of a spread curve and predict what caused them, which drugs can stop a given infection, which can't, and if not, why. We try to make it detailed enough to say what it was that made the microbes resistant, whether it was microbial DNA, the interaction between microbial cells, or the direct interaction with the drug. There are many things that physicians wish they knew when they prescribe antibiotics. And now any doctor can take a look at our predictions and quickly make an evidence-based choice of a personalized treatment. If we can adapt these tools for hospital use, we'll be less afraid to go to the hospital in general. We would manage the exact condition we got admitted for and have little risk of other hospital infections. And all because, well, infections can be made predictable. Thank you.